Good morning, everybody, and welcome to today's Autodesk Virtual Academy, brought to you by KETIV Technologies. I'm Nigel Mbaik here, Application Engineer, Customer Success Manager here at KETIV. And today I'm joined by a good colleague and friend, Javier Chavez. How's it going, Jav?
Good so far.
So far?
So far.
Just so far.
We're not done yet.
Yeah, so today we're going to be going over some Inventor sketching best practices. And I think I know at the very base of most models is a sketch. At least that's how most things are generated.
I can't think of a single part design that didn't start off with a sketch. So yeah, absolutely.
Yeah, whether that's on a piece of paper or a napkin or an Inventor, I guess sketches are everywhere. So we just want to make sure that everyone's, starting out right, making sure that from the ground up you're building everything correctly. That's what we're here to do today.
And I can guarantee that if you're maybe just learning it, just starting it, you could probably look at parts you started, in the initial stages of learning Inventor and look at them today and say, I wouldn't sketch that way.
Mm-hmm.
Right. So we're going to make that progress and take a step a little bit further just by, sharing some advice, sharing some best practices, sharing some things that we've seen cause issues in the past.
Certainly. Yeah. And I think one of the big things that, we want to kind of highlight too is performance issues. Right. And yeah. Sketching helps, alleviate some of those, even though you don't think they're related at all. Obviously, the more robust and big your sketch is, it's obviously going to take a few more resources. So I want to make sure we go over all of those things. So if you do have any questions anytime, go ahead and type those in to the GoToWebinar chat panel, and we'll make sure to address them either during the Q&A at the end or, when we find a little bit of a break while we're doing a small transition or something. So I think with that, we have everything we need to take care of before we get started. So I'm going to go ahead and pass it on to Jav, and
sure.
Let's get going.
So in looking at this, I kind of took a three-pronged approach, and I kind of categorized what I'm going to talk about in a plan, prepare, execute sort of stages, right? And so first thing, long-term planning for how we're going to use Inventor, we want to take a look at our settings. So there's some general settings that I think will help, right? And they're going to help in all different types of environments, not just sketching. And then there's some more specific to sketching, right? So keep in mind that, when we talk about best practice, it's a little subjective, right? Depends on what you're doing. If you're, a process piping person and you're doing a lot more piping and plumbing than somebody who's doing maybe some sketching for aesthetics, some of those rules could change, right? So just keep that in mind. The other thing we want to make sure we talk about is, how you prepare for that one part. So when I talk about planning long-term, how you want your sketch environment to be, in every single sketch or most of your sketches. And when I talk about preparing, I'm talking about preparing for that one feature or that one new part you're going to create in preparation for that. So the biggest chunk of information that's going to come out of this is going to be out of that last bullet point, the execute part of it. Right. And we could talk about how we do this all day long. Right. And we're going to make sure that we reference things like some basic rules, of course, but leveraging your interface, leveraging things like formatting and certain commands. Right. And last but not least, throughout the whole course, I think we'll give you some tips on how to, leverage the interface and leverage some of these tools and maybe, again, decide when to use some of these best practices. So let's take a look at the first part. On the planning part, we're going to take a look at some settings. There's some on the general tab when you go to application options, some that I like to put in here and check off. And again, you might, change your mind, but definitely when you're learning or you're exploring a new command, we're going to turn on some command prompting. I'll show you what that does. We're also going to change the annotation scale. So a lot of people have 4K monitors out there, and as you're sketching, these little icons or little bits of feedback get much smaller. So in order to see it, I'm just going to play with the annotation scaling. I do it all the time for training, especially because I really want things to pop on screen, but it really helps just in day-to-day drafting work or line work that you create in your sketches. We're going to change some settings there. Okay, on the sketch tab, there's some more sketch specific settings. There's some specific to just adding constraints all day long. There's some that are specific to working with sketches in the context of an assembly. Okay, so I'd like to go over those with you. I'm going to go ahead and switch over to Inventor and just show you what some of those do. All right, so let's start just by looking at this. I'm going to customize this a little bit. let's go to application options and start with command prompting. Okay, so it's not on. Everything's set to default here. I reset my Inventor so that it launches just like it does as you initially install it. I'm going to turn on command prompting, and that shows up on the general tab, right? And what that's going to do is every time I launch a command at my cursor, it's going to tell me what I need to do next. And specifically when it's sketching, if you're launching a different command, you might be prompted to pick points, select edges, whatever. It's going to do it at my cursor instead of way down here in the status bar where nobody looks. Okay, so something real general. I'm also going to change the annotation scale. So just to give you an idea of what that's going to look like, I'm going to change this for, I'm going to leave this alone for just a second. And I'm going to go ahead and open up a just a simple part, create my first sketch. Okay. And as I launch these commands, you can see here, I pick. It's going to prompt me right here at the command line to do stuff, as opposed to just doing it down here. Okay, and it's going to do that throughout all sorts of commands. The other thing you'll notice here is as I put in, dimensions, or I look at things like my projected line work or symbols, like this perpendicular symbol, it's a certain size. It's probably really hard to see it on your screen right now. And again, if you've got a 4K monitor, that could be worse. So I'm going to go ahead and come back here and make some of those changes. I'm going to go ahead and change this to an adaptation scale of 2. We already started seeing some of the command prompting. I'm also going to go ahead and jump over to the sketch tab. Okay, while I'm at it. So constraint specific settings, you want to go ahead and get these right so that the way you draw most of the time is reflected in these settings. So if I go here, right, there are tons of settings on what constraints sort of get inferred as you draw. Okay, and right now these are set to everything. So I'll go ahead and show you how these work. For the most part, the defaults are good, but again, every once in a while you're going to want to uncheck one of these because they keep putting a horizontal when you don't want one. It keeps automatically putting on a vertical constraint when you don't want one. Okay, so I'm not going to change these. I like these. The ones I am going to change are right here. Okay, there are times when I work on a sketch in the middle of an assembly where I don't want it to look directly at the sketch. Okay, and there's a setting for the part environment. There's a setting for the assembly environment if you ever have to create sketches in an assembly. And I'll show you what that looks like here in just a sec. I'm going to go ahead and uncheck that. And I'm also going to turn off the sketch display, or I'm going to turn it on so that we could actually see sketches through our parts. Okay, so I'm going to go ahead and change that to, we'll say 14, and we'll start to experiment with that. I'm going to come back to this assembly. So let's go ahead and get to a better view here, and I'm going to go ahead and zoom in here. And right away, if I go ahead and turn on a sketch that I want to work on, there's a sketch here. Okay, we'll turn on the visibility of that. And if you notice, I could see through the part and see the sketch. What this normally looks like, right, is this. I'll click OK, click Apply. I normally can't see that sketch. Doesn't matter, if I'm in an assembly or a part. But that opacity makes me, I have this sketch on, but I have no idea what's in it. I have to actually double click on it and see what's in it to be able to sort of grasp what that controls or what that does. So I like to do the following. I like to turn on the opacity. I don't really see a downside to having it on, except for maybe some graphics resources being used. But now I can see, yeah, this rib sketch, right, create some ribs here. There's a lot of geometry in here. Okay. And if I want to go ahead and edit it, since I have some of these other settings turned off, and I'll go back to the sketch tab here. There we go. In part environment, I don't want to look at this anymore. I could start just editing that sketch right away. So if I double click, okay, it's not going to do a look at immediately. And so I could just start working with the sketch as is, as opposed to it rotating and zooming in and doing that. Okay, sometimes you want that, sometimes you don't. The point is customize it to the way you look at the way you want to work. Okay, so Let's go ahead and get back here. I'll finish the sketch. Okay. And get back to the top level. Okay, so again, the meat of this is kind of coming here in some of the other things we're going to do. So in the prep stage, right, every time you create a brand new sketch, right, you want to go ahead and make sure that you think about the orientation of your part. Okay, when you select that first plane in order to sketch your base feature, you're going to want to think, well, am I sketching, you know, from front to back? Am I sketching from the top down, just depending on the component you're trying to create, right? That's going to change. And that's going to affect, you know, whenever you create a drawing for this, you'll be able to reference it and make sure that you're using the same terminology. The front is the front, the top is the top, the back is the back. Okay. And if you need to, you can redefine it. But ideally, if you want to pick this and do this right from the get-go, pick the right plane. Okay. So the other thing that's a best practice, and it's 99% of the time this is true, there's very few instances where it's not, is you want to go ahead and center that sketch to the origin. Okay, lots of ways to do this. Most of the time, you know, the basic rule when you start to sketch something is keep the sketch simple, and you know, try to leave out some extraneous features that you can place later. But we're going to show you how to do that, even if your sketch is a little bit more complex. Okay, so center your sketch, and then the last thing here in this stage is maybe, you know, projecting geometry, specifically origin planes, right? These origin planes never go away, so there's no fear of like deleting the XY plane or doing anything like that. The other thing is, if you're, you know, doing something like projecting a plane for symmetry, right? There's some caveats with, you know, if you draw this line from scratch, if you use a plane, it's infinite. Okay, and so you'll see the benefits here in just a moment. Let's go ahead and take a look at Inventor here for just a sec. And let's examine an existing part. So I'm going to go ahead and go to a part here, right? And it's one of the components on that seat that we just did. And this one's done right. This is literally the front, and this is right side up, so you can see the orientation on my view cube. Here's a part very similar that's done wrong, and I've colored it red so we can tell them apart. But it says that this is the back, right? And if I look at this right side up, you know, it says this is the orientation. When I create my drawing, I want a certain orientation, and it's not going to quite fit what the real orientation is. So it says this is the back, and when I rotate this to say, hey, where's the front? This is it. It's not really, that's not correct. And so if I go to create a drawing, this is where you're going to see this affected. All right, so I'm going to create a base view, and already this is telling me the front when it's not. I have to make some adjustments. In fact, you know, with large assemblies, if I turn off the preview, if I do this correctly, I don't have to see the preview. I can just know that the front is the front if I did this correctly and get my views to show up right. So let's go ahead and stretch this out. I'll go ahead and make this shaded. And if I do this according to what this says, right, this is the view I'm going to get for this component, when it really should be something more like this. So let's go to the other component, the one that's done correctly. Okay, this should be right side up, this should be the front, and we'll go ahead and bring that in. All right, this is more along the lines of what I'm looking for, and let's change that view just so we can see it a little bit better. Let's make it shaded. Let's take away the hidden edges. So that's really the front, as opposed to me looking from the back. So it affects your drawings, right? Just less work, and I don't even have to look at the rendered image to know that. Okay. All right. So centering your part to the origin. Let's come back to our sketch here for just a sec, and maybe you know, whatever we draw, right? Whatever we draw when we're starting to draw here, you got some shortcuts. This is way easier than it used to be. If you're starting with the circle, right, the first thing it does is ask you for the center. You're going to want to snap it to 0. Okay. And a couple reasons for that, right? If you don't, I'll show you what happens here. So yeah, we're snapped to 0. We're centered on this. I'm going to come back to the other part that's not centered, right? This red part. So let's go and open that up again. Okay. And this part, if we take a look at the original sketch that this got created from, it's like way off center. Okay. So when I go back to look at this in 3D and, you know, zoom all the way out, every time you go to sketch on this or edit a sketch, you know, almost every time, if I have my orientation set to, you know, look at the part, it'll do sort of a zoom extents and always zoom to 0. So if you can imagine, if this distance was like, you know, 100 feet, every time you would do a zoom all, it would zoom way out there, and you'd have, you know, geometry way out here. Okay, so you don't want to be that guy. If you ever open up somebody else's parts and it zooms way out there, that's why it's probably way off 0. And there's some times where that's okay, but 99% of the time, we want to go ahead and zoom in, center it on 0. Okay. So let's come back to another component here. Okay, let's examine this component. So here's another component. It's a fastener with some splines at the bottom. And if I just kind of go back in time, I don't know if you guys do this, but you can take your end apart and move it up on the timeline here. And this is the first thing we started off with, right, is this first feature. It's a revolve feature, and let's take a look at the sketch. Okay, so looking at the sketch, you know, they sketched on this front plane. Okay, great. It's kind of the same orientation here. And, you know, it works. We saw the fastener there. It works. But the way it was done here, they created some line work, a center line, okay, revolved it around. And what can happen here, a lot of times I'll see this, is one of these numbers can change, okay? So the number 1 dimension here, right, I'm going to go ahead and change that, and I'm going to extend the shaft length here to 2, okay? So great, I made this bigger, but as soon as I finish my sketch, I'm going to have problems. Okay. Part of that is because of the way the sketch was created, right? There's no coincident constraint connectedness to the end, so you could fix it that way. But this initial line was drawn from scratch. So if I was going to do this over again, right, I'll go ahead and edit the sketch. Okay. I'm going to go ahead and delete this line, and instead I'm going to project some geometry. I'm going to go ahead and project one of the planes here, the YZ plane. Okay, and even no matter how big this gets, the YZ plane is infinite. So, you know, I'm going to go ahead and change this to 4 inches, and as long as this is, you know, attached or constrained somewhere on this edge, it'll always resolve. So it doesn't look, it looks like there's a gap there. But I am going to add this constraint. Okay, it looks like there's a gap there, but if I go ahead and finish the sketch, let's see what happened there. I might be missing a constraint there. And let's turn that into a center line. So I think that's most likely what happened there. Let's edit that. There we go. So I lost my axis there for just a moment. But if I go back to this again, you know, I'll go ahead and maybe edit this just to exaggerate a little bit. I'll go ahead and make it 8. And again, you see that gap, right? It still resolves, even though, you know, you technically don't see it. That line is infinite. Okay. So I'm going to go ahead and bring it back down to what it was, right? Which was, let's say it was 1 inch, right? And it's restored. But projecting XY planes or YZ planes, they never go away. And again, they're infinite. So even though you only see them, you know, take up a certain amount of space, they go on and extend infinitely. So let's come back and take a look at some of our lists here. Okay, so prepping for some of this stuff, there's some basic rules now when we start to actually draw stuff from scratch, and these are some of them, right? No redundant points, so you don't want points on top of points. You want to make sure you have coincident constraints wherever you need them, right? Overlapping curves, so as you draw, make sure you don't overlap on top of the same line work, okay? You want to avoid open loops, so you just want to close that sketch, and you want to avoid intersecting loops. So think of a bow tie, right? You don't want that sort of twist and overlap that. So if you don't remember these, I didn't actually create a bullet outline list here. Look at the sketch doctor. Okay, so I'll show you some of these things you want to avoid. Another way to sort of remember this is to maybe just take a look at the sketch doctor. It'll show you what some of these best practices are in avoiding, these things. Every once in a while, you'll see a sketch. Nothing seems wrong with it, and then as soon as you edit it, you start to see what these issues start to cause, right? The problems that they start to cause. So let's go ahead and open up Inventor again. Okay, and we'll go to this here. So what we're talking about, right, is basically this profile, right? We obviously want to avoid, having a open profile. This will not extrude, okay? And then if you try to close it, this is the other thing you want to avoid, okay? That looks like it's closed, but the way I closed it, there's a line here, there's a line here. You want to avoid that, okay? The thing about the loops, okay, I'm going to go ahead and create a spline here, okay? This is what we're trying to avoid, is having these loops kind of overlap and twist over each other. Again, that's going to cause issues, okay? So if you're wondering, hey, do I have some of these in my sketch? This is where the design doctor comes in. Use it, leverage it, right? Especially if you're having problems. Once you have your sketch open, right-click, right? And you can go ahead and open the sketch doctor. Okay, tell it to diagnose your sketch, and these are the criteria. It's testing, looking for all of these things. Obviously, if you want to exclude a check for one of these things, you can. But when I click OK, it's sure enough, it lets me know, hey, there's some missing constraints here. There's some overlapping curves. There's a self-intersecting loop. And somewhere in here, there's an open loop because this never got closed. Right? So I basically, sort of recreated some of those issues that, caused some problems in a lot of these sketches. Okay. So, and I'll kind of jump back to this. If you do have, we were talking about centering your sketch. If you do have like an unusual shape, okay, and unusual shapes are a little bit more difficult to center in a sketch, right? Especially if you want it perfectly centered. So let's just say instead, maybe you create a rectangle and center that. So I'm going to create a 2-point rectangle, right? This is obviously centered. This is not really what I want necessarily in terms of what I'm going to extrude. So something you might do is build inside of that rectangle. So I'm going to change the geometry. I don't ever want to extrude this. I'm going to change the geometry so that it's a construction line, right? So this will never extrude. And then whatever shape it looks like I'm trying to create, I'm going to go ahead and create it within the confines of this box. So let's just say I have some type of unusual aluminum extrusion, right? I can go ahead and build this within the confines of the box. I'm going to go ahead and start this over. What I like to do when I do this is I like to build it outside and then move it within the confines of the box. So, okay, so here's my maybe unusual aluminum extrusion, right? It's got a lip here. Okay, and this could be a little bit harder to center. I'll take that and I'll move it inside the box, right? So there's a move command. We can just basically, tell it what we want to move, snap it to the inside, and then start maybe constraining this to the box. So guess what? As long as I have my box centered, this is centered. And I can start to define this, odd shape extrusion. And the box is really what's helping me center everything. Okay. So let's go ahead and come back and take a look at what else we want to talk about here. Okay. Fully constraining your sketches, right? That's a pretty big deal. The more control you have over your sketches, the better. And fully constraining your sketches is going to help. Most of the time, if we get some kind of tech support issue and there's just an assembly that's behaving just really weird, if you track it down, you'll track it down to one part. And if you look at the one part, I'd say, half the time, you can trace it back to a sketch that maybe is not fully constrained. Okay, so obviously we want to apply these sketches or these constraints, but you want to leverage, in order to do this as quickly as possible, right? Leverage your heads-up display. As you're drawing, you get all kinds of information flashing up on your screen, and you can basically constrain and draw at the same time. Okay. So while we're at it, if there's a constraint that we're not getting, we can sort of invoke that constraint. We can tell it what we want to constrain to. We call it inferring. There's some settings for that, and you can sort of choose what you want to infer to. So we'll use scrubbing to do that. Okay. And last but not least, leverage those dimensional constraints. You want to name those parameters. If you already know ahead of time that these numbers or these dimensional constraints are going to be important, name them. Another thing to note is a lot of times people have trouble with things like dimensioning to the outside tangent edge. So I'll show you how to do that in just a moment. And last but not least, right, there's ways to apply these constraints automatically and fully constrain your sketch. Okay, so let's take a quick look here. Let's start by maybe starting over with this sketch. Okay, so you could easily, draw a rectangle. Okay, and then come back and start to dimension it, define it, right? But it's going to take a couple extra steps. So what I'll do here is, again, I'll leverage my tools here to maybe center this. But as I'm doing this, if I'm going to go ahead and draw this and dimension it anyways, I'm going to go ahead and leverage the heads-up display. So that is basically the numbers you see here, right? And some of the prompts. So as I'm doing this, I know it's going to be 1 inch wide by 0.75 here. Okay, I navigate back and forth by hitting my tab key. So if I hit enter, I'm going to execute it. But if I hit my tab key, I can bounce between the two numbers. You see them flashing on the screen there, and edit those. The locks mean basically it's going to put some constraints and they're going to be locked in. In addition, right, we also use the rectangle command. So the rectangle command is going to automatically start putting in constraints relative to rectangles. So once I'm done, you can see some of those constraints. There's a parallel constraint that got added, right? You can see my glyphs are a little bit larger because of that annotation scale setting. There's a horizontal constraint being added. Every yellow dot means there's a coincident constraint. So this is fully constrained with one command. Okay. Now, in the next bit of geometry here, right, I'm going to start telling it how to constrain because maybe it doesn't know. Not every profile lends itself to the circle command or the rectangle command or an ellipse command. It just doesn't. So in this triangular shape that I'm going to go ahead and create, I know this bottom line needs to be 2 inches wide. Great, I did that. I use my heads-up display. Now the next dimension I want is going to be up to the very top of an apex, right? There's going to be an arc up here, so I'm going to go ahead and pick, okay? And I don't know the length of this line because I haven't drawn the rest of the geometry just yet. I'm just going to use a tangent arc here, okay? This number I know the radius, okay? The other number, the angle, I don't know. So I'm going to leave that one just blank. I'm just going to hit enter, and I don't define that. So last thing I'll do, okay, is start to close this up. Now, I want to go ahead and tell it how to constrain very specifically by scrubbing. So if I scrub geometry, if I put my cursor over it, you'll see I now get a tangent. It thinks that, if I get in the right position at the right angle, in this case, 127 degrees, hey, I want to constrain to that. Okay, well, what if I don't want to constrain to that? Maybe this next line is supposed to be parallel to this. Okay, then I'll just scrub it differently, right? I'll scrub this line, and then when I get to the angle that's right about parallel, in this case, 57 degrees, okay, I get a parallel symbol, right? I see it here and here, okay? I'm very explicitly telling it how I want to constrain, as opposed to, you know, doing this. If I don't do this, you know, I can just close it over here, and I am missing a tangent constraint here, right? In fact, I'm missing a coincident constraint, but I'm missing my tangent constraint and I have to go back afterwards and then add this constraint afterwards. Okay, so just less time. If you get used to picking and scrubbing or picking and inferring stuff, you can do that. Okay, and you know, while we're at it, you know, if these dimensions as you're creating them are important, you want to name them. So I'm going to go ahead and name my next dimension while maybe showing you how to dimension to this tangent edge. I'm going to change the color of my screen just to make this look a little better or easier to see. I'm going to go to my application options. And let's go ahead and change this to single color. There we go. That should make this easier to see. Okay, so the next dimension I'm looking for is the overall height. And what you'll find here when you're sketching, right, is basically when I go to dimension from this edge, initially wants to give me that length of the line. I want a dimension to the top here. If I just pick anywhere, it goes to the center mark. It'll do it all day long. Okay, what I see people do is I see them create a line up here. I see them, you know, make this line tangent and then dimension this way to get that dimension. And you really don't need to. Okay, if I start over, and I go from this bottom edge here, I want to watch my cursor. Okay, so I want to watch my cursor, look at the symbol next to my cursor. As soon as I get to right about 12 o'clock on the arc, the symbol changes, lets me know that if I pick here, I get the dimension to the tangent. Okay. So again, you want to fully constrain this. There's going to be some times where maybe you don't know what's missing as far as constraints go. So I'm going to show you another example. I'm going to go to AutoCAD here. And one of the things you can do, you know, is basically cut and paste or copy and paste. And I didn't start this sketch from scratch. So, you know, this is something that's coming from AutoCAD, right? Technically, it's not even a sketch yet, right? So I'm going to go ahead and window around this. And I want to copy and paste this. And the dimensions will translate into dimensional constraints. Some of the other line work, maybe not so much, right? I'm going to go ahead and copy this. There are no constraints inside of AutoCAD typically, but I'm going to go ahead and copy this, and I'm going to go ahead and, you know, put this into my new part. Okay. So when I do this, I right-click and I paste. I get this box, right, that basically shows the boundaries of this. Now, if I just click, I'm just going to get, you know, the geometry with nothing in it, right, with no constraints, nothing sketch specific. If I right click, I get paste options. Okay, it's going to, you know, assume, it's going to show you the units that it's assuming. It's going to always constrain the endpoint. So even if I didn't go here, it would have constrained the endpoints, but it could also apply automatic constraints, geometric ones, right? So I could put a check next to this, and if it sees two lines that are parallel, it'll try to put a parallel constraint. I'm going to leave it off for just a second, just to show you how you could do this manually. If you weren't cutting and pasting from AutoCAD, how could you do this? Okay, so I'm just going to go ahead and paste this right about here, and there's my geometry. The dimensional constraints show up here. Okay, they got translated from AutoCAD dimensions to dimensional constraints. Okay. Now, there's tons of constraints missing. You can see here, down here, it says, I need 24 dimensions needed. So a lot of constraining to do. You can see here, I could use a tangent from here to here. I could probably use, you know, parallel from here to here. Just to control this, especially if I ever want to edit this later, make it longer, I want to make sure it behaves correctly. So in our constraint panel, one of the easy things to do, right, is the following. You could launch this auto dimension tool, okay? And what I always like to do is it'll basically apply dimensional constraints and geometric constraints all at once. I like to do this. I like to uncheck the dimensions and get the constraints out of the way, the geometric ones. It won't pick up every single one of these that you see here, but it'll do a good 70, 80% of these. Okay, so I'm going to tell it here. It's asking for curves. I'm going to window around this and say, look, apply as many of these geometric constraints as you can. And when I click apply, look at this. I've only got 4 dimensions required. And those I could just start applying by looking at some of the missing numbers. But I can see here tangent, tangent, parallel, parallel. It picked up as many of those as we could. Okay. Now, if I now check the dimensions, it's going to add some other dimensions. Keep in mind, this is not centered, right? You might want to add some more geometric constraints to fully center this, and get this centered, you know, best practice again, right? But it might not dimension it the way you would. So I'm going to go ahead and now select this and get the rest of these 4 dimensions in. I'll go ahead and click apply, and it did as much as it could to do that, but it might not dimension the way you would. So here it added this 0.036 dimension. Just be aware of that. So in that case, I would probably remove the dimensions that it did put in and maybe put in some of my own. Some of the constraints I know it won't do a horizontal. So if you're trying to make this line horizontal, it won't do it. Same thing with vertical and a few others. But just putting in this horizontal constraint, you know, brings me down to 2 dimensions, and I can just continue adding some of these missing constraints. Don't know what's missing? Go down below, show all degrees of freedom, and you can see this thing can still move up and down, left to right. So it's probably your X, Y dimensions. Right now, I can go ahead and maybe center this both horizontally and vertically. Right, and you can see it's fully constrained. The only thing I would do different is I probably wouldn't dimension this the way, you know, Inventor decided to dimension this. Okay, so let's come back here. Right, and take a look at some more stuff. Okay, so one of the things you'll want to do is leverage formatting. This could be so powerful if you do it right and you do it early enough. So there's lots of formatting that we can do. We can format our lines into construction lines. They will not extrude, they will not revolve, they won't loft. So you can easily, change line work to do that. And what that does is when you go to do this extrusion process or revolve process, a lot of times you have to pick 2, 3, 4, 5, 6, 7, 8 boundaries. Okay, click, 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 and make sure you exclude other ones. Okay, if you make some of the line work, construction line work, it's going to make that easier. Okay, it'll exclude some of that information. With center lines, you'll get symmetrical dimensions out of these center lines, and so you could draw half of your geometry and work with that, and still refer to a diameter instead of a radius, or have to do the math. Okay, point styles, so you can control the points that you create so that they either show up as sketch points or center points, right? And you'll see the difference. Some will get picked up automatically by commands like the whole command or boss command. And it should make life a bit easier if you're trying to create a feature based off of these sketches. Okay. And then last but not least, driven dimensions. So every once in a while you get to a point where you're sketching and it says, hey, you're over constraining or over dimensioning your sketch. And most people hit cancel and they're trying to scratch their head and figure out, well, why is it over constrained or over dimension? You might want to keep those dimensions. You might want to leverage those dimensions. So I'll show you a way you could do that. Okay, so first things first, let's go and take a look at just construction line work and what it does, right? Let's get to a different example here. Let's go and open up another file. And we'll use this. We'll go ahead and use a the revolve part I had here. Okay, so if we kind of go back here, okay, if you remember, I had a spline here that got patterned all the way here. So I'm going to, maybe take a step back here and recreate the spline, and I'll show you the sketch that I use. So let's go ahead and share the sketch. Okay, and let's edit the sketch. Okay, so here, basically I want to create an extrusion. I've got a sketch here, and there's some geometry that shows up here. I use this line to kind of, control where this cut is going to show up. Okay, it's just a regular line. I dimensioned, 7.5 degrees, and then opened this up 15 degrees. I just use this as a reference. Now, it's only there for reference purposes. Same thing with, some of this other line work here, this yellow geometry here. And yet, I want to use it to cut geometry in an extrude function. So if I finish my sketch and I try to, cut that spline, the moment I click, E for extrude, I have to choose, is it this? Is it this? Is it, this? And sometimes, it'll try to split between these. And so if I start to, and you can see it's kind of flashing here, but if I start to maybe control and change the type of geometry this is, it'll make this picking process a lot easier. Okay, so let's go back to our sketch. Okay, and let's fix that. First, I never want to see this as something that can be extruded, so I'll change that to construction geometry. Same thing here. I'll change this to construction geometry. Okay, now this is projected geometry. There we go. You can still change that. You can see it's yellow but dashed. And when I go to extrude it, make sure I did this. All right, simple click here. There wasn't a whole lot to choose between. There's really just 2 boundaries as opposed to 3 or 4 or 5, and I can start to extrude and cut that. All right, so we'll just change the direction there, cut it up this way, and maybe just extrude it a 1/2 inch. Okay, so the formatting of that helped. Now, if I come back to the original sketch where we created the revolve here, you can see I'm missing some dimensions, right? Now, this line was the projected axis, and if I change the formatting, right, this is normally the way it comes in, just a solid line. And if I dimension from, this edge over to this edge, I'm always going to get the radius. So how big is that head supposed to be? Is it supposed to be 3/4? I have to do the math. And anytime you get us and math involved, there's always this chance for error. So instead, I'm going to undo that. I'm going to change this to a center line. Okay, and whenever you dimension from a parallel edge over to the center line, you get a diametric dimension, right? So you do that here. We can do it towards the bottom here, and again, we're going to get this diametric dimension, right? And I can refer to diameters like I would with the fastener, right? We'll make that 3/8 and 3/4 of an inch. Okay, so I'll come back now to another component here. Let's go ahead and take a look at this, and we'll do a couple things with this bracket. So a couple things with this bracket, I basically want to create a smarter component. So if I come back to the sketch, right, it just starts off as a rectangle, right? That created that first face. Okay, and then if I look at the flange, right, we just added a flange. The next thing that we added was this hole. This hole's based off of a sketch. Okay, so this is where we start to work with points. And you can see this point, as you draw these, by default, they get formatted this way. So wherever you get a point here, you have the potential to get a hole or a boss or something like that, right? And you can put them anywhere. You can dimension them. The way you control these, I'm going to hit escape here. You could select these and change the formatting. So I'm going to go ahead and select just a few of these here. And this is where you change the formatting. And so if you're applying holes to this, this will get a hole applied automatically, right? This will get a hole. Anything that's got this center mark attached to it will get a hole automatically applied. Okay, so finish my sketch. I'll kind of recreate this here in just a moment. Right, there we go. Holes are gone. As soon as I launch the hole command, it'll automatically pick up on some of these points here. Right, so let's go ahead and launch the hole command. And there's a couple ways we can leverage this, but let's go ahead and launch the hole. Huh, that's interesting. I'm not sure why I didn't do that there. Let's do it with a brand new sketch since I've used that one up there. All right, and we'll go ahead and change the formatting of this one. And let's launch the whole command from here. And you know what? This is the new whole command.
Yeah, that's fine.
Yeah, this is the new whole command that does this a little bit different. But normally what I would expect is this. So let me show you another one that will do this on. So we'll do it here. Okay, we'll do it with the rib command. Okay, and we'll put points here. Okay, and maybe one right here where I don't want a rib. Okay, so point, point, point. Everywhere where I want to point, this is a plastic part that maybe gets a rib. I'll come back to this, and when I launch the boss tool, everything that had a center mark attached to it just automatically gets picked. I don't have to pick these one by one. This one did not. It's not formatted that way. Now, you can always still pick it manually, but who wants to do that, right? So I've got a bunch of ribs there. Okay. So let's come back to this for just a second. And I'm going to reopen this. I'm going to save this. Okay. And we're going to come back to this sketch. Okay. So in this sketch, you can see here, okay, we dimensioned here. We wanted to control the first hole and maybe the last hole. Okay, and if you ever do this, you know, if it's already, you know, already fully dimensioned like it is here, I mean, the length of the angle's already been determined by previous features. So if I go to dimension this, we're going to get the following. It's going to bark at us and say, hey, this sketch dimension already exists. You're over constraining it. Sometimes it'll say that, right? And it'll also say something to the effect like, you know, do you want to create a driven dimension? So I'll do it maybe somewhere else. So I'll go ahead and do this here, right? So adding this will over constrain the sketch. Do you want to create one? Most people hit cancel and they don't get anything. You hit accept and you get a driven dimension. Okay, so that's basically what we've got here. So you could still use this. This is still a parameter. Okay, and if I look at my parameters, all my numbers, okay, it shows up here as a reference parameter. Now, I've already named it something. I called it start end. So I basically want that number to represent the start and the end of my hole pattern. As I make this longer, I want this to add holes. So leverage these dimensions, right? These reference dimensions or driven dimensions, and you can use them later to start, you know, patterning things. So that number got used in a pattern. And if I edit the pattern, and I start to maybe expose some of this, you can see here, there's a formula that says, hey, take that number, divide it by a max distance. My max distance, I don't ever want there to be any more than 12 inches between these holes. And I want to define the pattern from start to end here. So that 10 inches, that's where it's going to occur. And what you'll see here in just a second is if I make that longer, right, there's a length parameter. I'm going to go ahead and make it 18. And now, you know, my max distance is 12. It's evenly dividing this so that I never exceed that maximum distance. It's using the number between here and the last one, dividing it by my max distance and giving me a number of patterns to create. So test this again. We'll go ahead and make this 34, right? And you can see the max spacing parameter that gets created here. And the whole point of this is, hey, those numbers, right, in your sketch, let's go ahead and apply that. That seemingly, you know, seem to over-constrain the sketch can still be used in formulas in other places and leveraged. Okay, so some real quick, you know, time savers here, just in general sketching, some tips, a couple things, right? Right-click options. It seems obvious, but there's some things there that are like maybe more related to AutoCAD that I think you can use. So there's some point snaps, and there's a couple in particular that I think are really useful. And of course, if you're trying to create a some line work, it's kind of nice to be able to restart if you have to create, you know, separate lines instead of hitting escape and starting the command over again. If it's a loop, you can close it. There's also some shift or dragging shortcuts to create tangent or perpendicular geometry. All right, so let's take a look at those. All right, let's come back to this. We'll go ahead and sketch off here to the side. Okay, so as I'm sketching, right, I can right-click and close, just like I could in AutoCAD. So instead of, you know, picking here and doing that, I could just close, and it closes it. Okay, if I want to create a few separate lines, I don't want to hit escape and go click up here. I can right-click, restart. Okay, and I can start the same command. I'm back in the same command, starting a new set of lines. Okay, so here's something that's really interesting. So as I go to, you know, create some line work, okay, I'm going to start here. I'm going to right-click. I have point snaps. So these ones are real obvious. I can find the endpoint, midpoint, no problem, intersection, without really, you know, right-clicking. I think you could just snap to those. One that you can't find, right? Mid between 2 points. Okay, this is something from AutoCAD, and I could say, look, I want to go halfway between this point and this point. You could see where it's going to place it. Okay, and that actually applies as a constraint. So if I hit escape for just a second, you know, the farther this goes, right, I'm still equidistant from here to here and here, right? That's still an equal distance. Okay. Now, the other thing that'll happen, right, is as you're trying to draw something, you know, we got some shortcuts to draw things like slots, right? But that's assuming that the radiuses are the same. So as you draw, if you want to create, you know, connecting line work, you can pick anywhere here. And if you're closer to perpendicular and hold your shift key down, as you're holding your shift key, that line stays perpendicular to that and just, you know, stays connected to that. So it's making it perpendicular. I'm going to let go for a second. What I'm really after, if I get a little bit closer to tangent, is tangent. So I'm holding down my shift key, and now I can connect to this here on this arc, wait for that tangent symbol to show up, right? Those inferred constraints, pick. Okay. So same thing here. I'm just going to pick anywhere, no shift, nothing. Now I'm holding down my shift key. It's now tangent, and I can connect this and make a basically another, you know, sort of a slot, but without, you know, these even diameters. Okay. So lots of stuff at your right click button there. So we'll go ahead and come back here for just a sec, and let's go ahead and I think we were on this last slide. I think I closed it. Okay, so we saw some of those, right? And we're going to go ahead and take some Q&A here in just a moment. So
thanks again, everybody, for joining us today. We'll see you next week, same time, same place, Thursday at 10 a.m. Thanks, everybody. Talk to you soon. Have a great weekend.